We're here to talk about image management and using Mosaic datasets, working with image services within ArcGIS. Who's worked with Mosaic datasets and image services?
Oh, great.
Great, awesome. Make this much more easier, much more quicker. All right. So I'm Vinay Vishwambharan. I work on the imagery team. And Dan Zimble, he works out of the DC office. You want to introduce yourself?
Okay. I'm Dan Zimble. I work out of the DC office. I'm also on the imagery team with Vinay.
All right. So the topics that we're going to cover today, what we're going to be talking about, one is obviously the Mosaic dataset. What is it? The general information model, the anatomy of the Mosaic dataset. Then we're going to show you techniques and best practices to share out imagery. And lastly, a big question a lot of our users have is, I've got petabytes of imagery or I've got tons of imagery. It resides on the cloud. What are the best practices? What am I supposed to do? How am I supposed to serve this out? So I will be talking about that as well. So ArcGIS, it's a comprehensive imagery platform. So you've seen similar slides in the past where we've talked about how ArcGIS is a great platform. It is also an imagery platform. There's a bunch of stuff we've done over the past few releases. We now have ortho mapping, we have georeferencing, we have classification, we have a whole plethora of functionality and capabilities which we've included into ArcGIS. So it's a complete imagery platform as well. So there are three key pieces to this platform. This ArcGIS platform, it essentially provides a system of record, essentially managing and serving imagery, transforming all of this imagery into information products. Then we have the system of insight, wherein once you have these data sets managed, you create information products using our analytical tools. And lastly, sharing this imagery out, sharing these products out, it's a system of engagement. Now, in addition to all of these three things, one of the key capabilities or one of the key components of a complete system is obviously content. So as part of ArcGIS Online, we provide you with a ton of content. This content is either curated by Esri, or it's provided by our partners, or the user community. They contribute and we actually massage all of this data and make it available to you through ArcGIS Online. So, as one of the reasons why the Mosaic data sets, obviously, we need to manage and we need to serve out a whole collection of data set. I mean, that's a big challenge a lot of our users have. The imagery volumes over the past years have increased by magnitudes. The number of sensors out there have increased by magnitudes, and it's just going to increase. It's going to keep increasing. Now, ArcGIS, we actually integrate all of these imagery sources. So we have imagery that we support from multispectral sensors. We support various forms of satellites, aerial imagery, thermal imagery. There's radar data that we support. There's LiDAR data that we support. There's also full motion video that is natively supported from within ArcGIS. So the primary information model, it looks like all of you guys have already worked with Mosaic datasets and image services, but just reiterating on that, our primary information model to work with imagery is the Mosaic dataset. We have raster products within the system which treats imagery that's provided by individual data providers like Digital Globe, RapidEye, Spot, Airbus, so on and so forth. They're treated as complete products, and you can work with these individual data sets as well within ArcGIS. We have the concept of raster types, which essentially intelligently ingests imagery into this information model. It ingests images into the Mosaic data set. So we intelligently identify the metadata, identify the pixel information, identify the georeferencing information. Not just that, we know the processing that needs to be applied in order to make it a usable product out of the box. Mosaic datasets are eventually served out as image services, and these Mosaic datasets, they're typically authored using geoprocessing tools. We have a collection of geoprocessing tools that are specific to managing images using the Mosaic dataset. So there's a bunch of that which Dan will be talking about, he'll be covering in a couple demonstrations as well. So, why Mosaic datasets? We have imagery that's captured from multiple sources, like I told you before. There are different sensors, different satellites, aerial imagery. There's multi-temporal imagery, which means you could have stacks of images. How do you deal with that? You have imagery that's stored as multiple formats. Unfortunately, it's not a single standardized format. So you have GeoTIFFs, you have NetIFFs, you have Mr. SID, there's ECW, HDF, and that just goes on. So that's another big issue. You know, our users, they have these collections of data sets which they get from different organizations and they need to maintain or manage. So that requires some kind of cataloging mechanism, or it requires some kind of information model. That's why Mosaic datasets. The imagery that you acquire is not always 8-bit imagery. So the nice, pretty picture, 8-bit image, there is a lot of loss of information. Yes, it's used for visualization purposes, but when you want to do any kind of analytics, you want to store the imagery in its native format, in its native bit depth. Typically 11-bit, 12-bit, 16-bit maybe. So that's another issue, right? We have all of our data providers, they don't necessarily provide the data in the same bit depth. So there's a mishmash of all of these bit depths, but you still want to create a unified Mosaic dataset or a unified image service which you can use across the board for either visualization purposes or for analytical purposes. A big problem, metadata standards. Unfortunately, not everybody follows a standard metadata format. So when you're working with Digital Globe, they have IMD files which contain metadata. The structure is different from that of Spot, right? It's different from that of Planet. It's different from that of RadarSat. So they all have their varying metadata standards. What we need to do is, again, unify all of this into a single information model. That's why the Mosaic datasets. Sorry. Lastly, storage requirements. Each time you process your imagery, so for instance, I have QuickBird imagery. You receive it as level 1 basic products. Step 1, you need to orthorectify your image. You need to enhance your image, apply a convolution filter, pan sharpen your product, probably create a false color product, right? So I've just defined 5 different processing levels. So you've just increased the size of your data set by 5 times. So the storage requirements, using the traditional approach to actually manage your data set increases by magnitudes unnecessarily. That's why the Mosaic datasets, because a lot of this processing that we do is on the fly. Again, Dan will be getting into depths of all of this in a bit. So this is again kind of reiterating some of the points that I talked about in the previous slide. The Mosaic dataset, it removes redundancy, redundant data. It maintains information, all of the overlapping data. You're not creating a carpet of imagery when you have a ton of overlapping data. We maintain that overlap, we leverage that overlap. Again, I have a couple demonstrations that will show that. No need to sample your images up or down if you have a fusion of data sets. So we work with multi-resolution data sets as well. Disparate data sets. So if it's all over the place, you got imagery in Canada, in the United States, in Africa, you mosaic the whole thing, or you work with the whole thing in a Mosaic data set, there's no increase in data volume. Typically, when you create a mosaic of the data set, it's a large data set, right? It takes the extents of your complete extents of all your images that are covering your area of interest. We don't have that problem. We work with disparate data sets, so you don't really run into that problem. Image quality is a big one. Right? I told you there are 5 different processes which you potentially apply on your product to create a usable information product. Each time you create an intermediate product, or each time you process your pixels, you're losing fidelity of your pixels, right? So we try to reduce the sampling. We try to eliminate the number of times you're processing your image. So all of these 5 processes that I mentioned, if it just goes as one set of processing instructions, you've sampled your imagery essentially just once. So here's the traditional image processing chain, just again to give you an idea of what I just said. You orient your imagery, which is georectify or orthorectify your imagery, apply radiometric corrections, mosaic your imagery, tile your images, process again, and lastly, analyze or use it for analytical purposes, right? So there's a lot of intermediate processes, intermediate steps. So the latency involved to actually get this data to you, get it to your hands, get it to your users' hands is significantly large, right? Now with the Mosaic data set, you see all of those lines have gone away. The sensor data or the raw data, it gets ingested directly into the Mosaic dataset. Now the Mosaic dataset is just referencing these images. It's not recreating or rewriting these images in any way. Using ArcGIS image server, it's served out. All the processing instructions are stored within this Mosaic dataset. And as you're zooming, panning around, navigating around this Mosaic dataset, using it on your client, this processing is applied on the fly. And again, image service is an information model. So the Mosaic dataset, when you serve it out, you're essentially serving it out as a web service, or you're serving it out as an image service. It's a REST-based service, so you have access to the image service using REST capabilities. You also can access this image service using WMS. You can access it using WCS as well. All right. I think the next is a demo. Yes. So what I'm going to be doing now is, so I told you one of the key components of a complete system is content. So I'm going to show you some of the content we have and how it works with image services. So all of this content that I'm going to be showing you is driven by image services. We've essentially eaten our own dog food. Look at it in a good way, yes. The performance of these services, the capabilities of these services, they just speak for themselves. So let's browse the Living Atlas. So here's the Living Atlas, just a quick introduction before I move further on. Here's your source for all forms of content. You have different categories you can work with. There's base maps, there's demographics, not just imagery. There's demographics, there's transportation, boundaries, places, landscapes, landscape layers, there's ocean information, earth observation layers, and much more. So we're going to focus on imagery. You can pick what kinds of imagery. So I can say I need either base map imagery or multispectral imagery, temporal, event imagery, so on and so forth, right? And then I can pick specific layers that I want to work with, or a web map or web applications. In this case, probably search for NAPE, for instance, right? It gives me a collection of all the services that are essentially NAPE image layers. Now, one of the base maps that we have is imagery, and this imagery contains metadata as well. So when I say in terms of containing metadata, let's just hover over to Redlands. This is back where we have Esri. So big issue when you're working with base maps, you navigate over to your house and there are missing pieces. It doesn't look like your house anymore. Why? Because you don't know the data was captured. So these base maps, we've stored information which is relevant to the pixels or to the area that you're looking at. So I just identified this area. It tells me the accuracy of the pixel, tells me the date of capture. So I know this data that I'm looking at was captured back in 2015. The source of my imagery, this is a near map imagery. It's pretty high resolution imagery. right? And this base map is not just near map, it could be, for instance, click here, and the data provider in this case is NAPE, it's USDA obviously. Accuracy is about 60 centimeters, and this data set was captured 2nd of May 2016, right? So I think this is really rich, small capability of this base map, but in my eyes, my opinion, it is really rich information because you know the currency of your imagery and what you really are looking at, the accuracy and the temporal aspects. So next I'll just dive into NAPE imagery. So as part of the Living Atlas, we're serving out the NAPE imagery as well. Users have access to this as long as you have an ArcGIS Online account. So there's description which we provided for the layer, and you can open this directly within a map viewer. Not signed in. Sign myself in, and there you see the NAPE layer, right? And now as I zoom in, I'm looking at the false color representation of the NAPE image. Now the NAPE image is made available with 4 bands, so we make sure we're just leveraging all 4 of those bands. So it's not just a pretty picture, you can use it for analytic purposes as well. So for instance, you're just looking at a false color representation, it enables you, or rather vegetation pops out, it gives you a better rendition of vegetation information. So here's a natural color representation of the same data, right? And lastly, we have an NDVI representation of the same data. So this essentially is a normalized differential vegetation index. It shows you the relative health of vegetation in my area of interest as I'm zooming, panning, navigating around this map. Now, flagship desktop product, ArcGIS Pro, you can work with the same data within ArcGIS Pro as well. So I've loaded the multispectral image. I can navigate over to portal. As you can see, I've zoomed into my portal here, hit the Living Atlas, search for any data source, or I can jump to a category. There's imagery, multispectral, etc. I search for Landsat, for instance, and it returns all of the different Landsat layers. I've just dragged this in, you see it here as well. So here's the Landsat of the world. This is 750 terabytes of imagery. That's a Mosaic data set. 750 terabytes of imagery that's stored in S3, right? Every night there are about 450 scenes which are added to this Mosaic data set, so it's live. The Mosaic data set is live. Next, I'm looking at this imagery so it's processed right now. You're looking at a false color representation, right? And it seems like it's a mosaic that is projected to Web Mercator, auxiliary sphere. But as you know, the Landsat imagery is acquired, or rather disseminated, in different UTM zones. So the Mosaic data set is essentially reprojecting all of the information to a single projection, and it's hitting the raw pixels. That enables you to essentially have access to each and every band, so I can drive through all of these different processing templates. Not just that, let me pick another area of interest, one of my favorite places. The network's not being so nice to me. I promise you this is much faster. All right, there's a ton of clouds here, right? Because I've told the system, give me the latest imagery. Now, since it's dynamically served, it's a Mosaic data set, it's an image service. So like I said, we leverage the temporal aspects, and we leverage the overlap of the imagery. And lastly, there's meta information that's driving this Mosaic dataset, right? So in this case, I just want to sort all of my imagery based on cloud cover. I just say, give me all imagery with least cloud cover. And magic. So we've not really removed clouds here. It's just that I've sorted my imagery and it's just given me imagery with least cloud cover, right? So here what I was trying to show you, I went through a series of, in fact, oh yeah, there's one more application that I wanted to show you. Yeah. Okay, so here we have scientific data. We're working with multidimensional data as well. So there's seawater temperature, as you can see, seawater salinity, there's ocean current. So it's multiple variables within the single data set, which is a multidimensional data set. So I can pick different variables that I want to work with, click a point, and it gives me profile information. Like I told you, it's multidimensional. So in this case, it's giving me height information. So I can pick any given point. It gives me information about that. Or I can pick, now this is another thing which I also wanted to show. The multidimensional data, it comes with UV information. So as you can see, this is vector information which is also overlaid, right? Okay, so here the gist is basically what I wanted to show you. There is this whole magnitude of different data sets that I've actually went through, which I actually went through in this past 5 minutes, right? We went through Landsat. It's multi-band, multispectral, typically 16-bit. It's used for analytical purposes and visualization purposes, as you saw. There was a NAPE service. There was multi-dimensional data and base maps. You know, we've actually the complete spectrum, almost the complete spectrum of imagery types I just covered in there. All of this was managed and served out using image services. So that's, you know, I just wanted to show you the real potential and the true power of Mosaic datasets and image services. So that was that?
Back to slides.
Oh yeah. So that was my demo, and
okay. We're going to do a little handoff back and forth between various topics. Hopefully don't get too used to one of our voices for the entire time and sort of drone out. But so Vinay just went through a series of basic introductory level, high level discussions about the value of Mosaic datasets. And then showed you some of the free content that we provide through ArcGIS Online that are powered by Mosaic datasets. So we want to start talking about a little bit more detail about what the Mosaic dataset is. So we'll just very brief one slide, then we'll go into some demos and we'll build some Mosaic datasets. And we're going to build on that throughout the session. Let me go ahead and do the next slide. So what is the Mosaic dataset? Well, initially, the design of the Mosaic dataset was really sort of motivated by the need going back to ortho imagery and tiling imagery and having multiple CDs or other data content where you had all these tiles. And then you had to go find the CD from a reference and get the tiles. Well, when the storage got cheaper and the processing got faster, we could actually afford to put all of those CDs, all that data on disk. And so we wanted an ability to basically do this dynamic referencing of the tiles, or instead of going through the process of creating a persistent mosaic, we can minimize the amount of duplicative storage, so we create a Mosaic data set. So it's really both a catalog and a data set, right? So whenever I talk to customers, oftentimes when I talk about a Mosaic data set, it takes a couple of times to really have that sink in. And I kind of want to hammer that point here that this is a dynamic mosaic, right? It's not persistent. So there's examples where we were looking at the Landsat, 750 terabytes or so. Those are all individual tiles in the cloud. and we're just assembling them on the fly and providing you this mosaic. So it inherently has the properties of a catalog. It's got a table, and the table contains metadata that is populated when you crawl a Mosaic data set. And you basically crawl using something called, this is more Archish jargon, right? We invent our names for things, but we have this crawler that basically crawls raster types. And raster types are really the currency for a Mosaic data set. And there's a wide variety of different raster types. And Vinay mentioned that all these sensors are going up, right? Planet, you've got, 48 sensors this week or next week or something. So we have to keep up, and we have to build these raster types because they leverage not only the pixel data that's inside, that's really what you want is the pixel data to do analysis or to see it, but it also contains a lot of metadata. And a lot of that metadata is now not just when it was acquired, some basic standard kind of metadata. Sometimes it's more the georeferencing information. So this is direct georeferencing. All that ephemeris is going into the metadata, which we can leverage and provide enhancements to how the mosaic is mosaicing. So we'll go into a couple examples of that. But basically, it's this catalog, and it's an image. All right, so we'll switch over. So a question. A lot of you raised your hands earlier when we were asking how many of you work with Mosaic datasets. Can you just raise your hands again? For those of you who do work with Mosaic datasets, okay. So out of those people, we're going to do some little intro material here, but I want to know how many of those people that are using Mosaic datasets have used Pro to create Mosaic datasets? Can anyone raise their hands? One person.
Ouch. Ouch.
Right. Well, you know what? In preparation for this conference, I was like that, right? I use ArcMap. That's what I use. I use ArcMap because it's my comfort zone. I know how to use it. It works, right? But today we're going to show how you create Mosaic data sets with Pro and sort of get used to this next generation app.
I just want to throw in one line. ArcGIS Pro is feature equivalent in terms of imagery, and there's much more. I think he'll be showing you the function editor and stuff.
Yeah.
Move.
So there is, take your time, get comfortable. I understand. I have the same problem. So we'll just sort of intro some of that stuff now. So I have Pro open. I got a base map. And I'm looking at an enterprise, actually a file geodatabase in this case, from the catalog pane. And I just want to point out something about this because I love this. I don't know how many of you watched the plenary. Great. So a colleague, friend of mine, Sully, was on stage doing the top 10, right? And one of the things he mentioned in the top 10 was the catalog pane. Well, I don't know if in 1.4, I think in 1.4, this was called the project pane. And we kind of laughed a little bit because there's a lot of panes in ArcGIS Pro, right? Catalog was one of them we got used to in ArcMap. I remember Catalog was a separate app that we used to have and we could go to and use it, and it was like this totally separate app. And then we created this catalog window, which really was awesome actually, because it just made you having to switch back and forth. Well, so the catalog pane is back, right? And that's because of you guys. I mean, this is great feedback for us to help you guys make sure that we are minimizing the amount of confusion we're causing. So we appreciate that feedback. All right, enough of that. So I've got a file geodatabase, and I want to create a new Mosaic data set. So just like you could do in ArcMap, I can go right-click on the file geodatabase, or I could go to the geoprocessing tool, and I can create a new Mosaic data set. And when I create the new Mosaic data set tool, I'm going to get the geoprocessing tool that comes up. And because I right-clicked on the file geodatabase that I'm going to create it inside, it's going to automatically populate the storage location for that, right? So I'm going to give it a name. We're going to build a Mosaic data set that was collected from a Planix DSS imagery. So we'll just give it a name that sort of makes sense. And we're just going to leave the defaults. You can give it a product definition. We'll get into that a little bit later. Product properties. Suffice it to say that right now you're just creating an empty container. And defining that container is something you can do up front. But if I just leave the defaults and I leave it empty, then really what happens is when you add, the first time you start adding imagery or referencing imagery in your Mosaic, it's going to define those properties for you, the first item. So we'll create the Mosaic data set. It's going into the file geodatabase. And then it's going to add the empty container into my table of contents. And I'll have a message saying completed. So we go back to the catalog pane. If I can see now, I've got the empty Mosaic dataset of Planix Summer. And I can right-click on that. And again, the right-clicking ability to be able to easily get to the common tasks with Mosaic datasets is in Pro, just like it is in ArcMap. So I can add rasters. In this case, it knows that I'm clicking on the Mosaic dataset, so it populates the input for me in terms of the container. Now, raster types. So I wanted to show and talk about raster types for a second. Raster types is this currency of a Mosaic dataset, and this list will continue to grow. It has, I don't know when it started, but it was not as many as we have now. There's quite a few different raster types that we have. Every time a satellite is launched, we're building these raster types. There's even a new raster type that we implemented. I think it's on a GitHub site or somewhere, called the Python raster type. So if you don't want to be locked into our release schedule and you want to be able to add your own custom raster types, you can build your own. And we have a hook for you to basically hook into adding your own raster type here. When the default comes up, raster dataset, this is really for those images that have limited metadata, or we don't have a raster type for. So a TIFF, or where you don't have any metadata, but it's GeoTIFF and it's referenced, you can use raster dataset, and it's just going to crawl it. If you had, say, Worldview 2 or Worldview 1 or GeoEye 1 or any of these commercial satellite products or Landsat where it has the format and a TIFF, for example, for Landsat, I think it has, every band has a TIFF, with metadata as a text file, when you pick that, it's going to combine both of them together as it's crawling. It knows to look for that metadata with the pixels. And so it knows the georeferencing information because it's referencing the metadata. It knows the cloud cover because it's referencing the metadata. It knows a lot of stuff about that particular image because it has access and expects and knows how to read the metadata. So when you have these specific raster types, you're able to sort of crawl both and populate that table. I'll go into an example of that a little later. Let's just stick with the very basic one for now. So the raster dataset raster type. And these raster types do have properties. I'll get into that a little bit later, where you can specify even more fine-tuned how you want to crawl the data products. The processing templates are these pre-built processing chains for specific data products. So I'll show examples of that later as well. We're going to crawl a folder, and I'm just going to go ahead and point to that folder. So I've got some data, as I mentioned, from Planix. Let's go back to, right? So I'm just going to crawl. I have a bunch of TIFFs in here that are basically georeferenced. So I'm just going to crawl this folder. And again, I can leave these defaults. So just like in ArcMap and other things, we strive to have smart defaults. So go ahead and run it. So what it's doing is it's going out to my disk. It's looking for all the individual items that are part of that Mosaic data set and looking at the georeferencing information inside the GeoTIFF. For each item, it's building a geometry that extends for each item. That'll be stored in the table. It also is looking for any metadata that is associated with that image and populating the table with that metadata. And there's a core set of metadata fields in a Mosaic data set. That's ours, our schema, independent of Digital Globe or Airbus or any of those other raster types that we have or USGS. We have our own sort of core Mosaic data set data model. And what that controls is when you see imagery in and out. Because if you think about what a Mosaic data set is doing, it is basically looking at a set of rules. And those rules are, when do I display an image, at what scale, and in what order, depending on if I have a lot of imagery overlap. As you can see, I have some overlap here, but not a tremendous amount of overlap. So there's a lot of rules that go in there. We'll get into that a little bit later. But a lot of these core Mosaic data set values, the min pixel size, max pixel size, low and high pixel size, they're all sort of these lookup tables to determine for each image at what scale do I display. And we try to have smart defaults that allow you to not hammer your disk, right, to display all the images. So when I added all of them, the extent of that Mosaic data set was such that it determined, based on our defaults, that it's not very efficient for me to display all of those individual images. Because the Mosaic's going to have to go and read every single one of those images. I don't know how many I have. I think I have 44 images off disk, and try to create a Mosaic in memory and then send me an image. So by default, at this scale, it's not showing me them. But if I zoom in, it now shows me that, oh, I now only need to access 4 images. I can handle that, and I can now read those 4 images off disk, Mosaic them, and then provide me a picture back. So there's a lot of logic going on in the background of the Mosaic dataset, even at a basic level, right? So you'll notice that I've got this table. I can interact with this table just like you can with any kind of feature class. I can select, a couple of images, and you'll see those items highlighted in the table, as you would expect. Well, in some cases, you want to do some other sort of cleanup routines when you've got this data. So in this case, you can see that I have some of those black no data areas in my orthos, and I want to be able to clean that up. So I can go back to my catalog pane or to the tools. I can right-click on the Mosaic data set, and I want to modify it, and I want to rebuild those footprints. So by default, we're using geometry as the decision maker for where to define those lines, those footprints. But if you want to refine them, we have a mechanism to go in there and rebuild those footprints, in this case based on radiometry. So we have, some logic that's going in there and trying to determine where find the edge between the no data areas and the actual data values. Okay? So we'll use radiometry, and then sometimes the fidelity of the radiometry isn't quite perfect. So we have a little bit of fudge factor called shrink distance, and we can determine some value that we want to use. In this case, if you go in and use our measure tool up here, you can sort of get a sense of the distance between the widest gap here. And in some cases in this data set, I found 30 meters to be about the same. And the units that this is in is the units that the Mosaic data set is in, specifically where you're building it. So because I started building it based on a base map context, and our base maps are Web Mercator, which are in meters, it defaulted to meters when I created the Mosaic data set. If I were in if I had a geographic decimal degree sort of context in my map, and I built the Mosaic data set, your units would be in decimal degrees, which makes it a little bit tricky for this kind of stuff because it's kind of hard to make that conversion. So we'll go with 30 meters, and I'm going to run this. Go run. So what this is doing is examining each of the individual tiles, re-examining each of the individual tiles, and looking based on those rule sets, one, redefining the footprints based on the radiometry. So it's looking for that edge, and then it's going to update the geometry based on that other value I put in, 30 meters. It's going to find a new geometry for each image, and then it's going to go in 30 meters from there. I have a decent amount of overlap here, so should be covered. It takes about a minute to do this for 44 images, and you can see the output. It's sort of line by line going through each step. Another thing about processing with Mosaic datasets is all the processing applied to a Mosaic dataset is stored in the Mosaic dataset. There's a table in the Mosaic dataset that allows you to go back and look at all the processing that's been applied. So you can always go back to the Mosaic dataset. If I close Pro and open it up again and I want to see the processing that was applied to the Mosaic dataset, I didn't lose it because I closed Pro or ArcMap for that matter. It's stored in the Mosaic dataset as a table. Actually, this is a logs table. Open table and look at the logs table. It's going to show you the processing that I was applying in each step and each time. That's a convenience that, yeah. So as you can see, I've now cleaned up the Mosaic. I now have some of these hard lines in the Mosaic dataset, and we have other tools to even further refine how we can clean up and work with Mosaic datasets. For now, let's go back to slides. I need your slides. I can use mine, I guess.
Okay.
I can use mine. That's fine. Great. Okay. That was a backwards preview of the slide I'm supposed to be on. Okay. There. So we just created a Mosaic data set, gave you a sense of how you can do that in Pro. It's familiar. Pro is actually coming around with, there's a lot of new imagery features going into Pro. So that feature complete that Vinay was talking about is definitely there right now. You can do everything you can do in ArcMap in Pro. And it's a better experience for a lot of reasons. So working with Mosaic data sets. So this is mentioning to you that Mosaic data sets is this dynamic thing. We typically use two terms when we talk about Mosaic data sets. One is dynamic mosaicing. Dynamic mosaicing is basically a deck of cards and having a rule set that allows you to reshuffle the deck any way you want. If I want the kings on top, if I want the jacks on top, if I want the eights on top, I have control over how I apply that logic in a Mosaic data set. That's called a Mosaic method, and there's properties for how you do it. It can be based on the table. So if I have a table and I have a field that has date, and I want to Mosaic to represent the latest, most current time on top, then I can use this mosaicing method and specify the acquisition date as my rule set for doing dynamic mosaicing, the default. So anytime I connect to that Mosaic data set, whether through the Mosaic data set directly or through an image service, where the Mosaic data set's behind the service, that logic cascades all the way through to my client. So I can shuffle the deck any way I want. And you can have a default view that's sort of the best view. I think on the plenary stage, you saw an example where another colleague, Bernie, was up there showing some of the did you know, and he showed you, I think over Seattle, some digital globe imagery, and that rule set that he showed you at first was the latest, most current image over that area, but it had some clouds, right? And then he went to a property field and changed it to look at clarity, I think it was called. So it's just reshuffling the deck so that I don't want any clouds. I don't care about date. What I care about is clear. And so he was able to reshuffle that deck on the service. Mosaic data set for Landsat works the same way. Now, in addition to dynamic mosaicing, we also have a whole framework in ArcGIS that we refer to as on-the-fly processing. We actually call it raster functions. Raster function framework. You might hear a couple of different ways of talking about it, but essentially what we're talking about is on-the-fly processing. And when we mean on-the-fly processing, we're talking about only process the pixels that I need. So if my extent is at 1 to 1,000 scale and I'm looking at a global image, I don't want the global image processed. I only want what's in my screen processed. So that's really what we mean by on-the-fly processing. So every time I pan, right? Every time I pan at that extent, or every time I zoom to a different extent, it's only processing those pixels within the extent. There's a variety of different functions that you can use to create different types of on-the-fly processing, extracting bands, doing a hill shade or a shaded relief. Even some of the pre-processing steps that are pretty normal image process chain type operations are available in the raster function toolset. You can apply these to individual items or rasters or images that are in a mosaic. You'll hear and read in our documentation or in our language us refer to these as raster items or items in a mosaic data set. The items in those things are the individual records is what we're talking about when we talk about items. So these chains are either appended at the item level, where the processing for each item is unique, or they can be processed at the Mosaic dataset level, where every item in the Mosaic dataset has the same set of logic. That's what we mean by on-the-fly processing. And this is kind of how it works if you think of a raster function, right? You have an input, which is an image. You'll have some pixel block that's coming back, just the amount that you need from your extent. Then you're going to have some function, which is going to create an intermediate product in memory. And then that's going to be disseminated out through the rest of the chain into the service or into the desktop or into any other kind of system. So you get a collection, you have imagery on your disk. When we talk about keeping currency, however you get it, whether it's a ground station or it's, I got a disk drive with a bunch of images from a provider, I have some kind of repository where I have imagery. You have a raster type for that type of imagery. You create Mosaic data sets, right? It harvests the metadata if it can find the metadata. It leaves imagery in its original form, and you can apply raster functions on top of it. And we'll show some examples of that later. Then, of course, if you connect to your ArcGIS desktop or ArcGIS server as an image service, then you get back your imagery. Some examples of how this works. So this was something that we did a couple of versions ago. This was applying a simulated atmospheric correction. So this is Landsat imagery that you're looking at. And then when you apply an on-the-fly processing to derive a new view of the data with the atmospheric correction, you clean up the image so that you have a normalized looking image. Another type of capability is color correction. So you'll have tonal balances across multiple images collected from different dates. In the case here, I think it's Landsat imagery collected at different dates, different sun angles, different atmospheric conditions. And you want to normalize that to have a single target color kind of model for the whole collection. And you can apply the color correction to that on the fly through the Mosaic, or depending on your use of the data, you may want to persist it. You may want to say, I'm using a Mosaic data set to apply all of my processing, tune it up the way I want because I'm building a base map, right? I'm tuning it up to make it look nice. I don't want to see those hard edges. I want to have seam lines. I want to do feathering. I want to do ortho on the fly, all that, dress it up, do a color correction, tonal balance it. Okay, now I've got imagery the way I really want to use it. Now I can create a permanent cache, right? We can create a cache off of this, which is faster on disk to access from a service than reading an entire image. So going back to that seamline idea, we do have a seamline generator to help sort of get rid of those hard lines. Our eyes like to see those straight lines, and our eyes typically go to straight lines, and the Mosaic can look a little funny otherwise. So we have seamline generator. So let's go do another demo quickly. We'll show some dynamic mosaicing. So we built the summer one, but you may have seen when I was browsing through this example that I actually had a mosaic that had several different seasons over the same area. So if I open this table, for example, you'll see the similar values that you saw earlier, except now I have a field that I added called season, and I have values for autumn, summer, winter, and then I know it's not a season, but there's also a color infrared set in there also. So what we can do with that now is I've got them all inside the same Mosaic data set. Right? So here's my Mosaic data set. I've got 4 times the number of footprints than you saw me build earlier because I've got 4 different collections. over different times of the year. And if I were to zoom to a particular area, say zoom, pick one, I'm going to get some result back based on a default rendering rule. So remember those Mosaic methods? So I basically have this tuned so that I'm seeing a Mosaic method using a raster function that shows me summer. And if I go to the new data tab, which is in Pro, if I click on the layer, there's a lot of layer context. This is something you're probably still getting used to if you're starting to work with Pro, or you will have to get used to it if you haven't started working with Pro, is this notion of context. It does take a little while to get used to, but I promise you I'm definitely, at least I'm finding it quite useful as I start working with it. So I've clicked on the layer, and you'll see the Mosaic layer context menu here. That will only appear if it's a Mosaic data set, right? If I click on number layer, it changes. So as a Mosaic data set, Mosaic layer, I have control over a variety of things. There's a data tab that's specific to a Mosaic data set, and there's an appearance tab specific to a Mosaic data set. And the appearance tab really takes a lot of the properties of an image, right? I have control over the enhancements, I have band combinations, stretch types, dynamic range adjustments, things like that I have access to. In the data tab, though, we have something called processing templates. And processing templates are really a way of attaching different ways of viewing the data to a single mosaic. In Vinay's demo, I think Vinay went through and showed you the Landsat services and showed you different views of the Landsat service. Well, those views are really not X number of different Mosaic data sets. It's one Mosaic data set that has, a couple of filters on it. That's another way of looking at it. They're these processing templates that are attached to that Mosaic data set. It's like a different processing chain that I'm going through when I pick that. So I've got a couple of ones here that are basically calling out. It's a simpler one. I'm not doing any image processing here. I'm really doing some fancy selection. But I've got summer views. I have autumn views, right? So it's going back to the Mosaic. I've got an autumn view of the data. I've got a winter view of the data. And I've got a color infrared view of the data. So it's one Mosaic, and I'm able to associate all of those different raster function templates that we have to this Mosaic to allow me to dynamically mosaic. If you look at the catalog and we take a closer look at that particular Mosaic data set, there's something called the Manage Processing Templates tool. This is something new in Pro. It allows you to create sort of those channels. You can create thumbnails of the image you want. You can promote one to be the default for your Mosaic data set. And you can actually access the function itself by clicking this Edit button, or you can create more detailed properties about what that is. So for example, on the autumn view, if I click this Edit Raster function, I've got a basic stretch function listed here. So this is the new raster function editor in Pro. And this is the function that's being applied when I actually change that different view of the data. And in there, I can tweak how I want that stretched. And then in the properties of the Mosaic data set, I can determine whether or not I want it to be calling the summer imagery or the autumn imagery or the other imagery. I think that's enough for sort of the on-the-fly processing, dynamic mosaicing. We'll switch now back to Vinay, and we can come back to this a little bit after if you have questions. You ready?
You're on sharing? I think you're sharing.
Can you go to the next one first? I have to do something. So we'll just go to cloud and we'll come back to that.
Okay.
Okay.
All right. So I said one of the key components I'll be talking about is working with Mosaic data sets in the cloud. This is typical so the Landsat scenes that I just showed you, our data sets completely reside on S3. Or rather USGS, they make the imagery completely available on S3. That's what we're hitting. Our image services, they spun up on Amazon instances. So it's a complete cloud-based infrastructure. So what I'm going to be talking about is managing this imagery on the cloud and best practices for the same. So what are the advantages? This is still fully not well understood and adopted by a lot of our users, not just ArcGIS, but across the board. Why would I move to Amazon or any other cloud storage for that matter? The advantage is obviously low cost, resilient storage, low cost enterprise compute. It is simpler to install the whole enterprise solution using a cloud builder. And we have a simple scalability solution as well, where we just leverage the scalability that's provided by Amazon. Disadvantages, obviously, you need to upload all of your data. There are different types of storages which you need to understand, you need to work with, and it has to be interoperable in your infrastructure. There are major infrastructural changes as well. People see this as a big disadvantage. Again, there are potential security concerns. If you're behind a firewall and that's how you operate, you're locked down, then yes, there are security concerns, and the cloud is probably not the best way for you to move forward. And that's why I've listed it as one of the disadvantages. And again, there are complex data policies, which is on the lines of data access policies, which again is on the lines of security. So what's changed over these years? Previously, we accessed our imagery as standalone direct access. So imagery that resides on my disk. I had all of my data on my disk. We didn't really work with large volumes of imagery a few years ago, probably decades ago. You could just store everything locally, pull it into your desktop, work with the data. Next, we had NAS solutions. We had these enterprise solutions, which again was on-premise, right? It's a file-based system which you store it on-premise. You have access to it through your various clients, your web client, your desktop client, so be it. And now we're actually leveraging the cloud to actually maintain, or rather serve out data across organizations or across a complete enterprise. You're leveraging the elasticity of the cloud, the elastic nature, the elastic infrastructure of the cloud to actually store and serve out your imagery. So that's how it's gradually evolved. Optimizations you need to keep in mind, you need to consider, is you have to enable elasticity to actually get the best power out of working with the cloud, and you need to enable caching. I'll be talking a little more about what I mean by enable caching in a bit. All right, file format considerations and optimizations. Firstly, you need to tile your imagery. This enables partial access of your imagery. So if you look down there on your extreme left, I've mentioned bad, which is a bad implementation or a bad storage format of your TIFF or your image, which is, it's one complete raw file. So there's no tile-based or partial access to your image, right? If you zoom to any area, you have to work with the entire data set. It's the complete raw image that you have to work with. So if it's tiled GeoTIFFs, it's much more optimized, easier to work with and decode and access by a system. Compression. Compress your imagery using either lurk compression or using JPEG compression for storage purposes. Lurk is what I'd recommend, but then again there is a trade-off between storage and transfer and additional compute, because there is additional compute involved in decompression of your imagery. Not significant, but that's something which you need to consider based on the volume of hits you have to your server. Always have pyramids within your imagery. It just optimizes everything, the whole dynamic mosaicing capabilities. You're taking it to a much lower scale, to a much larger scale. And oh yeah, there's one more piece. So the last part, or the extreme right, you can see the most optimum way to store your imagery is MRF, as I'd recommend, is 3 different file structure. So the file structure here is three separate files. So the metadata essentially is just an XML file which points to an index file. The index file essentially just points to the raw data file, right? So when you're accessing your imagery, you're not hitting a whole bunch of pixels. You just hit the header, identify the areas that you need, and then that makes a request accordingly. So this MRF file format, it's originally designed by NASA. Essentially, it splits the raster, like I said, into three parts. The MRF file, which essentially is a pointer to files, to two files, the IDX and the data file. IDX is a simple index to the data, to the raw data. The format is an open source implementation. It's part of GDAL 2.1 and beyond. The file, it provides you with varying types of compression options, including lurk, which we recommend. I can give you more information about lurk probably after the presentation, or even if you come by the island. This is natively read by ArcGIS. So MRF file format is now natively read by ArcGIS, and it can be written out as well by ArcGIS, via ArcGIS. So how do you convert your data to MRF? So we have optimized rasters. I'll point to the link. Okay, down there, right there, you can see the link. github.com/s3/optimized rasters is where you would want to go. We have a little white paper as well on how best to use optimized rasters. It's designed to convert your raster, probably which is stored in a suboptimal format, to a cloud-friendly format, and your GIS application ready format, right? You can translate or convert all GDAL supported formats into an MRF file format. We provide you with a Python toolbox. There's a command line interface, and there are Python scripts as well, which you can use. We provide you with a set of predefined templates. So if you're working with QuickBird imagery, for example, or Landsat imagery, you can just pick a template that says, my source is QuickBird imagery, go do your magic. And accordingly it knows, this is the metadata file, this is where it's supposed to be stored, this is what the data structure is supposed to be looking like once the conversion is done. Given the tool, or given this, as you can see on the right, you can easily modify a set of parameters. You can find the compression, tile size, and all of that of the output. This also includes the data upload and download options. So where do you want to upload it? Is it local? Is it on-premise? Is it your Google structure, your Google storage, Azure, or is it going to be Amazon? You can specify profiles, which includes your access keys. It can include your credentials to actually get onto your systems to store your data. This can be run independent of ArcGIS, so you don't have to be from within you don't have to run this from within ArcGIS. Like I said, it's available as a Python script as well as a command line interface, so you can actually run this outside of ArcGIS. You can again schedule this to run periodically as new data arrives. That's how our Landsat data works as well. Like I said, every night it's being updated by 450, 500 scenes. We've automated the process such that as new imagery comes in, it's just automatically converted to MRF, and it's actually stored in an optimized format, and our Mosaic datasets and image services are updated automatically. So back at 10.5, we also further improved ArcGIS image server working in the cloud by including better support for cloud storage, utilization of RDS for Mosaic datasets, as well as we provided you with a set of best practice workflows. Towards the end, I'll actually put up a slide which shows you links on how to get access to these best practices and these workflows to actually work with your datasets. We're also working on simplifying the installation of ArcGIS image server. In these cloud infrastructures such as AWS and Azure, we do have the enterprise builder, which I think was part of the top 10, the enterprise builder.
It was not in the top 10, but it was in the plenary.
It was at the plenary, so I don't know if you guys had seen that, but it significantly improved the whole deployment of the enterprise in general. So, quick summary. Do you want
You keep going. I'm
to? Okay.
challenged.
So, quick summary. The things we talked about: Mosaic datasets. It's our primary information model to manage imagery. It provides you with dynamic mosaicing, on-the-fly processing capabilities, reduces latency, increases pixel fidelity, and there's no intermediate data storage, which is one of the key, messages you have to take away from here. It's accessible across the platform as web services once you serve it out as an image service. Running ArcGIS on the cloud is suggested. If you have petabytes or large volumes of imagery, it makes it accessible with lower latency. Again, storing massive volumes of imagery on inexpensive cloud storage, that's another bit which we briefly talked about. We recommended optimizing data for performance. I briefly showed you a couple slides on how to do that. And lastly, using elastic compute for ArcGIS image services, essentially spinning up multiple instances of Amazon as required. So the Landsat service was a typical example, right? We don't stand up 200 servers. It just scales based on demand. So based on demand, it spins up servers, and as it's done, it actually shuts down servers that are not needed. So this is the website that I mentioned. A lot of those cloud-based workflows, imagery workflows. So the tab you're looking at is image management tools. You can see in the middle there's image analysis tools as well, and there's imagery use tools as well, which we are providing. Keep visiting this because we're updating this constantly. We have a team who's just working on imagery workflows, and their focus is to just simplify, all of these handling of historical imagery, scanned imagery, elevation data sets, browse images, so on and so forth. And yes, I had one more slide, but questions? Okay.
It's probably getting time anyway.
Okay. So yeah, any questions? Go on.
You were showing the Landsat.
Uh-huh.
As you know, the Landsat images come as individual bands.
Right.
Download them to
Right.
yes,
Right.
with different pixel size
Right.
60 meters. So how do you handle that?
So firstly, so his question was Landsat. I showed a few examples of Landsat. Now Landsat comes with multiple bands, and each band is a separate image, and it comes with multiple pixel sizes. How do we handle that? So like I said, we have the concept of raster types. Dan had shown that as well. When I pick a raster type which says Landsat, we've essentially worked with the data provider and asked them, what's your data structure like? What's your metadata look like? If I have to work with this, or if a user has to work with this, what is a usable or a useful product for him? So based on that, going back and forth, they've advised that a multispectral product or a pan-sharpened product are two typical products, right? To create a multispectral product, you need to composite all the bands together. To composite all the bands together, we use our on-the-fly processing capabilities. So that's how we're compositing and creating a single image on the fly behind the scenes when we show you the imagery. And we do the reprojection as well on the fly, and that's why everything is in a single projection. As for pixel sizes, we have multiple services. One is a pan-sharpened service, so it fuses the 15 meter with the 30 meter color. We have a pan-chromatic service, which is only 15. Then we have thermal data sets as well, which just takes care of the 57 or 60 meter resolution imagery.
You will bring all the individual files together, copy them, bring them into Mosaic.
No.
So we're just referencing those. Do we have a Mosaic?
No, but we can show the function.
Okay.
So let me just
switch. So he can show you the function chain, what it looks like.
Well, not the chain, but I'll just show you. Probably should have showed this to you earlier, so let's just expand it. So this is the raster function list, right? So you can use any of these with a Mosaic dataset, either at the item level, at the individual record, or at the Mosaic level. So Vinay was talking about the composite function. So we have a composite bands function that'll basically be used to assemble all those individual images for, say, Landsat multispectral. And it knows, as I talked about raster types, the raster type is designed to know, it doesn't matter which one here in this case, but I'm going to go back to the raster type here. So with the raster type, you have all sorts of different ones here. So we know that Landsat, for example, we know that Landsat has multiple bands to it for that raster type. We design it to know that. And in that raster type, it actually can tell you what product you want to use, right? So we have all these different products to pick from based on the data. We have all the bands listed that you can work with for Landsat 8, right? And we have these listed as processing templates. So these are these processing templates for that particular raster type. You can see how complicated this gets. I mean, it gets really complicated when you think about it, what's going on. We try to simplify that by building these raster types for very well-known products. But really, it does come down to, if you're with a big organization and sort of govern your own, product specifications, then it really comes down to, if you're using Mosaic datasets, to really think about what it is you're trying to provide the end user. So it's a real design exercise of what am I going to share? What am I going to share? So you got to think about how you stitch together all these chains together, just like you're building a product. And you can do that with our tools to design and build those products. The on-the-fly processing becomes very handy because you can kind of see results immediately as you start tweaking each one of those processing steps. So we went through that exercise ourselves when we were creating the content for the Landsat services and understanding how to sort of best represent the end product as a function chain. Does that help a little bit? Okay.
Yep.
Yeah, so there's a lot of on-the-fly processing going on here. Where exactly is all of this flying going on? Is it on the...
It's on the server.
It's on the server.
Yes.
Yep.
So the server contains the logic to basically go through that process chain. And there is one thing we didn't talk about. Obviously, we can't talk about everything, but there's another thing that's relatively new, is the raster analysis role of image server. So raster analysis is this new capability that we have. If you're creating a finished product for the world of Landsat, and you want to persist that as a product that anyone can reuse without it having to go through all the gyrations of this processing on the fly, you can use raster analysis to basically persist the result. And you can do that in the cloud. So you can have, we did at the plenary, the Chesapeake Bay Conservancy, or Chesapeake Conservancy had that land cover example where we're persisting that as a product in the cloud using raster analysis. But behind the scenes, it's a Mosaic data set or a set of imagery with a bucket of imagery with some processing logic applied, and then it's just cranking through those on-the-fly processing per chunk, right? And then it's moving that tile over into a new bucket that is your new data set. So there's a way to do on-the-fly processing where it makes sense. If you want to be dynamic and on-the-fly, then there's other cases where you want to just generate a big product for some area.
Yep.
Associated with it. There's the templates are something called raster function templates. You'll see an RFT, and they get packaged with the Mosaic data set when it gets deployed to the server. So the server doesn't have to go calling out for some process thing at some other thing. It's local to the server.
Yep.
You had mentioned the benefits of using meta raster format when you are running image server in the cloud.
Mm-hmm.
Do you recommend MRF if you are running your own local?
You can. Yeah. So the question was, we recommend MRF in the cloud. What about if you're doing it in your own local instance, if it's on premise? yes, you can do the same there as well, because essentially, like I said, it's 3 files. It's highly optimized in the sense that you have an MRF, which is a single tiny file, then you have the IDX, which is tiny too, and these essentially just point to the data file. So depending on where you want to store, the data files, it just makes access simpler.
So picking on Landsat, you get geotiffs from USGS.
Yeah.
Are you recommending then we use the tool to then convert to MRF?
I think it depends on your ultimate. If you have thousands of users and you're storing it in low latency and you're talking about petabytes, right? Many terabytes of data, you got to really assess like what's the benefit. Like throwing a TIFF on S3, you're going to get really bad performance. So it's just a high latency environment. You're going to be tossing stuff around. It's object storage. It just doesn't perform the same way.
So there's 2 forms of this MRF. I didn't really talk about the second one. So what we're talking about is a raster. The core MRF. It's a real MRF format, but we have something what's called a raster proxy. A raster proxy essentially is an MRF file, which is an XML, which points natively to the native file format. Like in this case, Landsat, it points to the geotiff. We're not replicating the entire geotiff, we're not converting it. So it points to the geotiff, and we write out a caching location, right? So the data is stored in S3. The caching location is ephemeral drives, which is probably 10 times faster than S3. Sorry, 10 times more expensive than S3, but it is faster, it's much faster as well. So what we do is, as a user zooming and panning around, the MRF accesses the geotiff. When it makes a first request, it caches that out to the ephemeral drive. Subsequent requests, they go back to the ephemeral drive. Every night, we strip down these ephemeral drives, and, the next night again, as users are zooming and panning around, they start building up the cache again. So yeah, there are 2 forms of MRFs.
Another question, but real quick, just as a reminder to the people leaving, if you please would, do the surveys. We really like the feedback. Just a quick note. But yet another question. Yes. If you're doing at the item, so the overviews are built on the top of the logic of the Mosaic. So whatever rule sets you have, whether at the item level or at the Mosaic level, the overviews are built based on it builds the cache bottom up.
Okay, because a lot of times I notice when I apply a stretch function to a raster item, to clear up a lot of times over water, it's really deep or really purple or something. I can clear that up at the raster item level, but then when I build the overview, it doesn't always apply it. It's better. It always seems to be a little bit, all that piece of that you always.
Yeah, I think maybe if we can take that offline, I'd be happy to, both of us would be happy to talk to you about those issues.
Island. Yep.
Okay. I think that's it. Thank you for coming.